Welcome back. This is now a new video in the popular casual game mechanics series. We are going to be covering the I call it the agility, dexterity, and timing mechanics. So this is based on a game called Tiles Hop, or there's so many variations of that. So the ball's going to jump forward, and we're going to just with the mouse we're going to kind of drag it to where it needs to be on the tile. So it's going to hop from tile to tile, and we got to hit the correct tiles. And as we go along, this is normally a rhythm-based game. So at some point later on, I want to make a video on kind of how to instantiate or spawn uh, these cubes, potentially at a random location along the x-axis based on the beat or the rhythm of the song. So we'll do that uh, in our systems and our ProcGen videos that we're going to cover later on. We just want to get the base mechanics of all these kind of different popular mobile game, hyper casual game mechanics working first, and then we can talk about all the other bells and whistles. So let's get started. We're doing this one in Bolt. So I'm in my Bolt scene. I'm going to select my player. I'm also, well, just going to split these screens up so we can see them side by side. I'm going to select the player. We are going to add a flow machine to the player. And like we did with the previous camera, so we've got the camera, so I'm just going to delete this camera. I'm going to go to one of my previous scenes, which is makes no difference really. Let's do the swerving one, wrong one. I'm going to grab the camera and my scene variables. Because remember how we built it in that my video, my simple follow camera video. You can go and look at that. It is in the series along with this popular casual game mechanics. I'm going to go back to my agility dexterity one. Just going to paste it in here, and the camera will now follow the character because it's got its own code on there to follow, and it finds the character based on whether it's tagged as player. So I just got to make sure I tag that as player. Okay, so now that we've added a flow machine, let's actually create a script. Go to our scripts folder. I'm just going to call this one agility dexterity timing. There we go. It's a mouthful. Controller. You can call it whatever you want. You could probably abbreviate it to ADT, whatever it is that you want to. And now that that's done, we're going to click on the open flow graph. It opened off to the side here. Sorry about that. Okay, so what do we need to do? We need to do a few things to get this working. We are going to first and foremost, I'm not going to make it, there are several ways we could do this. We could make the level itself move towards the player. But in this case, I want to actually get the player to move forward. Every time the player bounces down, it's going to launch itself forward into forward like that. So that's the idea. So I'm just going to lift them up off the ground a little bit. Potentially just move the camera back a little. It's just a little bit tight on the player there. And so we're going to get him to, as he drops, he's going to bounce forward. So he'll only bounce forward if he hits a platform. I'm trying to kind of like if realistically, because if it's just moving forward at a constant rate, you might get some weird stuff. It might just look weird. So I'm just going to, this is the best way I could think of to get the timing right and feel right. So we're going to delete the start for now. We're going to use the update. Sorry about that. Ooh. Just taking a look at my notes real quick. Okay. So in the update, we're going to do the movement, so we can keep that there. I'm going to maximize this viewport. So the next step is to do an on collision enter, because every time we collide with something, we are going to want to add forward momentum. And for this to work, we are going to add two variables in the object variable tab. So the first one is called forward movement. Let's call it forward hop. There we go. Forward bounce, even better. Forward bounce. It's going to be a float, and based on my notes, I'm going to make this, let's round off to 5.7. Again, this will be dependent on how you've laid out your level, how far apart the platforms are. This is based on the ones that I have here. Probably going to have to tweak it again, and this is going to be up bounce. I guess I could have just called it bounce, but up bounce, and that's going to be a float, and that is going to be 6. So it's almost the same amount of velocity up as it is forward. So those are the values we're going to use. We're going to drag off this, and we're going to go, and first thing I want to do is always make sure that I kind of zero out the velocity first of any kind of incoming force, because I don't want to get any undesirable results. Every time the character, the little ball bounces, I want it to bounce at the same height. So I want to first and foremost, I'm going to say rigid body dot velocity set, and I'm going to set the velocity in all directions to be 0. So I'm zeroing out any kind of movement, so that the movement that follows is going to be pure, and it's going to be clean, and it's going to have no lingering force coming from the previous movement. Okay, now we can do the exact same. We're going to do a rigid body dot add force and mode in the brackets. I'm going to choose impulse because I want it to be kind of snappy. I want it to be poppy. I want it to be quick. And what are we going to do here? We're going to do a transform dot up to get add force in the up direction. We are going to multiply that value. So we're going to multiply the up by the, not the cheapest, by the up force. There we go. So that's going to make it go up. And then we're going to add this. So we're going to add, cheapest. We're going to combine that, and then we'll just plug that into the result. And then we're going to, I'm just going to duplicate this, and we're going to replace a few things and plug that into B. So first thing, I'm going to change the variable up to be the forward, and I'm going to replace this transform.up with a transform.forward. And now we are adding the up, so we're multiplying the value by our up direction, multiplying this by our forward, that one by our forward direction, combining the two results to give us the final output. We're going to put a comment group around this, and let's just call this bounce movement, I guess will be good enough. Bounce movement. We can test this out to see what that looks like. So when the ball hits the ground, it should bounce up and forward. So it should kind of reach round about where this tile is here. Wait, I think I forgot. This ball level was originally taken from another one, so I'm going to make sure use gravity is on so that it actually falls. And yes, I still want to freeze the rotations. Again, you might want to have a little bouncing bunny or whatever it is. So I don't want to have any kind of, there we go. So every time it hits something, it keeps bouncing forward. There we go. So we can try that again. So this is all, so as it hits the ground, we zero out all velocity, and then we add new velocity. We launch it forward, like boom, 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 and boom. There we go. So now it's working. So these two values together, combining them together, the forward movement and the upward movement, will get you the desired distance. And again, it will always be the same distance, because what we're doing here is we're zeroing out any kind of velocity before we actually move the character. So then, now that that is done, the next step is to like kind of find where my cursor is, raycast into the world, and then move the ball to side to match the movement of my cursor. Exactly like Tiles Hop. Go look for it. We'll share a link in the description so you guys can see it. I just don't want to have it in the video because I'll get copyright issues, but I'll share a link to Tiles Hop so you can see kind of where we're going with this. Now, next step is the top here. So there was something really cool that I did in code that I wasn't able to figure out in Bolt because I was trying to add a variable that didn't exist, and then I went up here and I tried to add the unit options here, but then I still got a few issues. So both videos are going to be done the same way so they stay consistent. So I'm going to create a new quad. If you're wondering what a quad is, it's essentially a plane, but if we're going to the wireframe, it is a just two triangles, unlike the Unity plane, which is heavily, like it's a very high poly piece of geometry. So we're going to grab this quad and I'm going to parent it to the camera, and then just zero out all of its rotations and positions. There we go. And we're just going to scale this up a little bit because this is going to be our raycast area. This is where we're going to raycast to. And once it's done like that, I'm just going to move it away from the camera, kind of, just kind of where the ball is. I'm thinking it's safe to say that. And then I'm just going to scale this up. Let's call this raycast hit area. And again, like I said, there was another way in code that I found where we could generate the plane in code. I just haven't been able to figure out how to do it in Bolt. So we're going old school on this, and it still works. So I don't know why we wouldn't use this. Okay, so now I don't want it to be visible in the camera, so I'm going to simply just remove the mesh renderer like that. Just turn it off so it's not visible to the camera. And we're going to add a layer because remember we're working with raycast. So I'm going to select this and create a new layer. I'm just going to call this hit area just so that we can assign this new layer to the plane we just created. So tell that this is the hit area to look for when we're moving, when we're raycasting into the world. Okay, so now we can go back to our code. So back in the code over here is where we're going to do our raycast. So we're going to be raycasting every frame. So raycast. And we're looking for physics.raycast, and we're looking for ray because we're going to be using the mouse position into the world from that point. So we're looking for raycast ray, and we need the hit info to get the position. We need the distance and the layer mask. That's it. So we are looking for max distance, hit info, ray, and layer mask. That's what it looks like. There we go. And again, we're just going to add we're going to add a branch here after the fact, but we'll do that once we've kind of done the raycast logic on this side. So what do we need to know? So if you've worked with raycast in the past, we're going to be searching for a camera.screen point to ray. Just a standard position one is fine, screen point to ray, and we're going to plug that into from the line, diagonal line to the diagonal line so that they connect up. And the distance here, I'm not too bothered. I'm just going to put something like, I don't know, let's try 10 meters. And from here, what do we need? You can see there's a little camera icon here. So we're going to drag off the camera icon and type in camera.main. So what this does is it gets the main camera, the one that is tagged as main in the scene. So if I select the camera here, you'll see that under the tag name, it's called main camera. So that's what that's looking for. It's looking for the camera that is tagged as main. So this isn't the optimal way of doing it. I would, actually, let's do it the right way so we're not doing any complete kind of rubbish coding stuff. So in the graph, we're going to add a reference to camera like that. And I'm going to tag it as the variable, the variable type is going to be camera. And we're just going to drag that in and plug it into where it says self. We haven't got the camera just yet, but we will get there. Don't worry about that. So what do we need? The position. That's simple enough. We're going to go input.mouse position. We're getting the mouse position. So we're saying look through the camera that's currently active, find the mouse position, and save that as a point that we can then raycast from. We have the distance. All we need left in the layer mask is we're going to just do this very basic. We're going to go and do a layer mask literal. Select hit area for that layer mask literal, because remember that is the area that we want to hit and find the location. Okay, now we just need to do a branch. So I'm going to drag off here and say if. That's what a branch is. It's an if statement. And all I want to do is only when my button is down do I want to actually do something with this raycast calculation. So we're going to go if the raycast comes back as true, and from here we're going to go input dot get mouse button. So what that means is it's not get mouse button done will fire off once when the button goes down, and get mouse button up will fire off once when the button is up. Get mouse button will come back as true as long as I'm holding down the mouse button. And I'll leave it at 0 because I want it to be my left mouse button. And that's it. So if this is true and this is true, then we're going to do the whatever is after that. Okay, so again, just double checking, taking a look at my notes. Yeah, now we just need to, we are going to transform dot position. So we're going to go transform dot position set. And in this case, because the character is already bouncing up and down and bouncing forward, the only thing we care about is splitting this off into a new vector 3xyz. I only care about the x position, which is the side-to-side movement. So the rest are going to stay the way they are, but the x position is the one that I am concerned with. So I'm going to drag this further across here. And just to, keep that as it is, we're going to type in transform.position get, and we're going to say v3.y. Let's try that again, v3.y, and we're going to go v3.z. So y we're going to get from the current object's position, and the z we're going to get from the current object's position, because those we want to keep as they are. We don't want to mess with those. Now we're going to do a little bit of a lerp. We don't want it to be too poppy, too snappy. We don't want it to instantaneously the ball jumps to where the cursor is. We want to have it a little bit of an interpolate, or a small kind of like time to get from location A to location B. So from X we're going to drag out, type in lerp. Go. That's the one we want. So A is going to be coming from this, so we're going to go and say v3.x. So we're getting the current position. So whenever you're interpolating, actually only specifically for movement, you're going to get the current location, or the location that you want to start at. Actually, let me just duplicate this so it doesn't become too like wires crossed kind of situation. We're going to keep it nice and clean cut. So this is the starting point, and we're going to need to have a endpoint for this. So, and then we're going to need a time, how long it takes to interpolate to that position. So we're going to create a variable in the graph here called, let's call it player x. Let's call this new x position. So this is the new x position. It's going to be a float. If you're wondering why I'm using a float, it's just because I'm only using one of the values, so I don't need both. I just need a float to contain the x position of the character. Okay, and then the last thing is going to be in an object variable, because I want to call this lerp speed, so we can control how fast or how slow the character will transition from where he was to where the cursor is. And that's also going to be a float, and I think we're going to set this to 5. Because that's a relatively slow amount, but it might be fast enough or slow enough depending on, we'll test it and see how it goes. Okay, so I always multiply it by time.delta time to make sure that it is frame independent. So it's always going to be reliable as far as the result that you get, not based on frame rate issues or frame rate drops or whatever the case may be. So that's going to be what we're doing there. Let me just give myself some room here. Okay, so that is just the starting point. This should do everything we need. But remember, we don't actually have this value. Where is it? The new x position. So we need to do that. So that's where we're going to set it here. So we're going to hold down Alt and go to the graph and hold down Alt and grab the new position. And let's just plug it in here before. So we're going to get the position before we do anything else. And where is this position coming from? It's coming from the hit info. So we're going to drag out. We're going to type in point. And it's called raycast hit point. And all we care about again is the vector 3.x. Where did it hit in the x position? There we go. Okay, so this is phase one. It's going to be a little broken, so we're going to go in and develop this, make this a little bit more robust. But as it stands, all that's left to do is we need to actually specify where the camera is, because the camera is empty, remember? So we're going to add a start. We're going to add a few things to the start, but for now we're just going to be setting the start here. And at the start, we need to do two things. We're going to go hold down Alt and drag in the camera, hold down Alt and drag in the position. There we go. Plug those two in, and I'll tell you what I'm doing right now so we can talk through it. So at the start, we need to get the camera. So we're going to do that. We're going to go and say camera.main like we did before. And plug that into there. So now we have a reference to the camera. And on the new position, all I want to do is go and say, I want to grab, actually just duplicate that, I want to grab this and say, at the start of the game, please find the player's X position so that we don't get any weird, because if we don't, because this value is set to 0, wherever your object is in the world, it's going to try to move to 0 when the game starts. So at the beginning, we want to say, find the camera and set the initial player's X position, this new one, to match where the player is currently right now. So that's what we're trying to do there. So let's try this out and see what happens. So hold down the left mouse button will allow me to move the ball. See there's a little bit of a delay after the fact, but it is working, and that's because of my lerp speed. So if I make my lerp speed faster, and let's just maximize on play so you can get a better view of what's happening here. There we go. Now it's a lot more responsive, but it's still got a nice kind of soft animation feel to it. But there we go. Now notice how what the problem is here. You won't see it when we maximize on play, but I do want you to acknowledge the fact of why we're about to do what the next step is. If I take my, I'm going to turn off any forward force so I can test this without having any weird issues. There we go. So it's just going to bounce on the spot while I move the ball around. This is weird. I can't my cursor, my mouse. What is happening here? Oh, it's because the raycast ends. Okay, so let's make this a lot faster. And okay, so you'll notice that when it actually happens, because I'm having a couple of performance issues on my PC trying to make this video whilst recording it and all that. So I want to make sure that when my ball goes to either side here, it stays within the confines or the boundaries of the level. And I also want to make sure that I think there's more than enough space on this camera. Okay, I'm going to make this raycast area a little bit bigger. Sorry. Just big enough. It can be facing the camera, or you could just simply make sure that it is, I guess, rotated like that to the floor. We could try that. So we could raycast it like that so we can get a better hit result. Not a better hit result, but something that I guess makes a little more sense. So I'm just going to move that object down to where the ground would be, where the camera, and the crossover there. Let's try this again, see if that gives us a better result. There we go. That is a much better result. So notice how I'm able to go complete. So yeah, just let's unangle that rotation. I thought facing the camera might make sense, might be better, but the reason I parented it to the camera, that way I don't have to keep generating a new plane. This plane will follow the camera, therefore wherever I raycast it will be attached to the camera. So So that's my idea for why it's attached to the camera like that. So the rotational value looked like it was about 60 degrees to kind of flatten it out. And I think I can bring this down to about 10 again. I think now the scale wasn't the issue. Let's just test this one more time. Okay, that's good. So let's give it enough room so it doesn't feel like my movement is obstructed. There we go. There we go. Okay, so that's working quite nicely. So now what I want to do is make sure that my ball can never ever leave the level side to side. It could also be up and down. This can work for both, so just be aware that it can do both. Sorry. Okay, so let's go and do that in the code. So we're going to grab our player, and at the beginning of there we go. At the beginning, at the start, so we're going to be adding this code over here, but first we need to update it at the start of the game. So at the start of the game, we've got the new camera, we've got the new position, and all we need to do now is get the boundaries of the screen, if that makes any sense. So inside of the graph here, we're going to say screen boundaries. I'm going to make this a vector 2 because I actually only really care about one screen boundary, so I'm not quite sure if I don't think I need to do both, to be completely honest. But I'll do it anyway, just so that you know, for those of you who might want to be able to restrict it in all directions. So screen boundaries, this is going to be the X, which is side to side, Y, which is up and down. And we are going to hold down Alt and drag in this variable to set it. We're going to plug it in here, and I'm just going to start commenting out these things in the start. So put the start outside of this. I'm going to put a comment group around here, and this one is set the camera and start position. There we go. And then the section here is going to be about getting the screen resolution. So to get the screen resolution, we are going to just grab the camera here, or we have the camera here, up to you, because now that we've referenced that camera, we can use that. And we're going to go and say screen to world point, screen to world point, and that's going to be the result that we need in here. And instead of using the mouse like we normally use or anything like that, we're actually going to we need to actually split this out, because we need to be very specific about what we need here. So X is going to be simple enough. We're going to right click, and it's going to be called screen.width. Because remember, X is the side to side, which is your width. And we're going to right click and add screen.height. Get the height of the screen. And then the last one is just going to be this camera again. So up here, duplicate this one more time. And I'm just going to get the position of the camera in the Z. So I'm going to go here. I'm going to go transform.position.Z. Sorry. Oh, yeah, no, we have to do that after. Sorry. No wonder I was trying. We're going to go v3.z. Plug that into the Z position. So any of you who've ever used the screen to world point, if you don't actually put anything in the Z value, you get some really weird results. So in this case, in this particular case, I'm not too bothered. I just want to make sure that this matches. Just for me, it needs to match where the camera's Z position is. Okay, so now we have the boundaries of our, let's call this getting the screen boundaries. Borders. Maybe borders. Yeah, borders. There we go. And that's all that's left to do is I want to get the scale of the object, and I'll show you why when we test it. You'll see what happens, but let's just do the logic here so that when I do it later on, when we don't have to come back here, I can just kind of show you what it does. So we're going to create a new variable in the graph called player x bound. call it scale. Actually, it makes better sense. Scale, and it's going to be a float. And we're going to set this. So we're going to drag this in, and we're going to set this after the fact. Now what this is we're going to get the spheres, like all geometry in Unity has a volume that surrounds an object, and we call those the bounds or the boundaries of that object. So I need to know what the boundaries of this object is so that I can use that to make sure that the object doesn't go out of the frame. And again, you'll see what I mean when we do it. So how do I do this? I'm going to first get the component. So I'm going to go and say get component. If I had typed that, get component, and we're going to say game object.get component type. And what is the type? We're looking for the mesh renderer, because the object that's actually that's doing the rendering to the screen is aware of the boundaries of the object, the scale of the object, if you will. And we're going to drag off here. We're going to type in mesh. Just type in bounds, and let's just choose the one that says mesh renderer dot. No, I'm too lazy. Let's just type it. Mesh renderer dot bounds. There we go. Okay, it's not a typing day for me, so there we go. We're getting the boundaries, and all I care about that is one boundary, which is the x. So I'm going to go v3.x. Again, if you need to be able to grab, if you need to know both, why will you not? There we go. Oh man, I need to get the size first. So now that we have the bounds, I'm going to go and type in size. Get the bound size. You need to get the actual physical size of that object, and we'll need to divide this in half. The reason for that is, think of, in this case, think of we're getting the diameter of the object, like if you talk about spheres, and if I do the bounds the way it is now, if I don't divide it, it's going to stop somewhere over here because it's going to keep the distance of that object away from the edge. And all I want to do is say find the from the middle point of that object to the extent of the bounds, so that it will get as far as that and will not go past that point. That's all we want to kind of do here. So we're going to divide that by a float and just put in 2. So we're dividing that to get the half size, if you will. You can try that out and see what happens if you don't if you mess around with that value, and you'll see what I mean. If we just divide that by 1, and you'll see straight away. So let's just say get player bound size and divide by half. Okay, so now we've done all of this kind of like prep work at the start of the game, where you can go and just down here, before we actually update the position, we need to limit that position within the bounds of the screen. And we've done clamps already in the past, so we're going to just talk that through again. So we're going to be taking, and we're only going to be clamping this value here before we actually lerp it. Make some more space. I'm going to drag off here. I'm going to type in clamp. And what value are we clamping? We're going to grab in the value that's coming in. And we're going to make sure that it doesn't go past a certain position. So we're going to grab our screen boundaries. And we're going to grab our player position. And we're going to do a few things here. So the first one is let's lock it. And this way we're just going to lock it to the left side of the screen and the right side of the screen. And the left side of the screen is going to be our minimum value, and our right side of the screen is going to be our maximum value. So all we're worried about with from the screen boundaries is our vector2.x. There we go. We've got these two here. We're going to do this twice, but we're going to, you'll see what we're going to do here. We're going to, this one we're going to add our player offset, player scale value, like that. And we're going to plug that into our minimum value. And again, just making a little more space here. And all I'm going to do is essentially just duplicate. I'll just see what we need to duplicate, because we're just going to end up, let's grab these three here, just duplicate those so we don't have to, at least don't have to do all of that. And because I'm going to try to explain this as best as possible. So the reason, what we're doing here is we're saying on the minimum value, which means this side of the screen, we're adding, actually let's just do a demo here. So when we're at the end of the screen here, we're saying, when you get to the end of the screen, we're saying, okay, add half the player scale to push it in. But because we're now on the right side of the screen, we get to this point, we're saying, by the way, take the player scale and subtract that from that side instead. So here we're going to add it to keep it in frame, and here we're going to subtract it to keep it in frame, so that the rest of the next section is making sense. Okay, so now we know the boundaries here, but I'm going to take the boundary value, I'm going to multiply it by, to get the negative value. So I'm going to multiply this and make it I guess it could have been an integer, -1. So I'm saying get the negative boundary, the value, and we're going to subtract that from that. Plug it into there, and that should do as far as the locking of your screen. So we should no longer have any objects flipping around, I mean like leaving the screen. So we're going to test this right now. You'll see my cursor will leave, but the ball will not go past. So we're bouncing. Oh, we're getting an error there. Hold the phone. What do you mean you can't? What are you saying here? Apologies, I'm trying to figure out what it's shouting at me. Okay, so I figured out what the problem was. Let's just do something before we fix that. Just make sure this raycast hit area is convex, and if it's a mesh renderer, a collider, and is trigger, just so that the ball can't actually bounce on it. So I made a mistake in the start. I'm on the camera. Over here, I forgot, after the mesh renderer bounds mesh size, I forgot to get only the X. And then I divide, so I put get vector3.x, divided that by that value, and plugged it into there. So that's where I was getting it. It was trying to convert a vector3 to a vector2, and it was getting all sorts of errors. Okay, so that should do the trick. So let's test this out now, and hopefully everything is as advertised. So the ball's bouncing, hold down the left mouse button, move it. There we go. So I'm also now going to stop the bouncing altogether. So I'm just going to disable everything so I can just test the one system. So I'm going to make sure that I disable gravity on this just to test this side-to-side movement, and we'll go from there. There we go. So you'll see it no longer. Okay, so if you guys realize you're having weird performance glitches, make sure that this window, when you're truly trying to see performance, isn't visible. There we go. There we go. So it will not, wow, there we go. Yeah, my machine is struggling. Hold on a second. It is. Okay, so that's it. That will lock it into place. You'll never leave the frame. And if we turn everything back on again, turn the gravity back on, add forward force again. I think mine was 5.7 if I remember correctly. And let's just play it in full screen mode so we don't have the graph done here. And let's see what we got. Camera follows by itself from the previous. There we go. That's it. Hopefully that's helped. Hopefully you liked it. Be safe and watch out. Keep an eye out for the next videos. So see you then. Cheers.